So we talked about perpetuity as of now. Okay, this question, we have done this question and understand this thing. When we talk about perpetuity, there is no specific maturity for a bond. When we say this is a perpetual bond, so the property of a perpetual bond is they do not have any maturity date. So we refer to these bonds as perpetual bonds or perpetuities. Okay. So when we talk about perpetuity, now understand this thing. I'm saying this is time zero and this is the timeline. But where does my timeline ends? And for a perpetuity bond, my timeline doesn't end. So this is one, this is two, this is three, this is 10 years and afterwards. So this time actually keeps on going till infinite. This is the perpetuity bond. And if a bond is paying me coupon payment of $10 first year, every year, so how much am I willing to pay for this bond? This is what perpetuity bond denotes. So till the end of the time, this bond is going to pay me $10. So how much am I willing to pay for this bond at what is the present value at time is equals to zero? And understand, remember one thing. So this there is a difference in between the calculations when we talk about beginning of period and end of period. Here, if you look and observe closely, this is at the end of first year, beginning of second year. This is at the end of first year. This is at the end of second year. This is at the end of third year. This the perpetuity, the we are not calculating the present value here, but we are calculating the present value at time zero, not at time one, but at time zero. Now understand this thing and remember this thing. There might be some kind of questions where they will ask you after 3 years, what is the value of this kind of a bond? So after 10 years, what is the value of this kind of a bond? So what would you pay for this kind of a bond? There might be these kind of questions. Okay. So let's not look. Let's start with our next example here. So our next example, it's about zero coupon bond again. So zero coupon bond with a face value of $1,000 will mature 15 years from today. The bond has a yield to maturity of 4%, assuming the annual compounding. What is the price of the bond? So annual compounding, price of the bond. The more questions we do, the better. The I mean the concepts are being tested, so we actually develop a better understanding. That's why it's very important to do as much as questions possible. So the face value is $1,000. So what does this mean? Always try to make a timeline at time zero, at time 15 years. This is the face value. This means this is the future value of the bond. $1,000 you are going to receive. So future value is $1,000. Bond as a yield to maturity means I slash Y is 4%. Annual compounding, 15 years is the time. So number of years is 15 years. We do not have any payments because this is a zero coupon bond. So this means that PMT for this bond, PMT for this bond is zero. So what we are actually, we actually have to calculate the present value of the bond at time zero. So how do we calculate this? I'm going to share my calculator with you again. Always remember to clear all the calculations. Second, clear work. Now the N is 15. This is the 15-year bond. The interest slash yield is 4%. payment is zero. I'm saying that there's a future value of $1,000. So how much am I willing to pay for this bond today? So I'm going to compute this and click on my future value. For this bond, I am willing to pay 555.26. So the answer for this question is $555.26. So today I'm going willing to pay $555.26 for a bond which is going to give me $1,000, and throughout the tenure of the bond is going to there is no payment, then there is no coupon payment. At a yield of 4%, I am willing to pay $555.26 for this bond. The next question here is Freddy bought a car worth 42,000 today. He was required to make a 15% down payment. The remainder will be paid as monthly payment over the next 12 months, with the first payment due at time one, given the interest rate of 8% per annum, compounded monthly. Now, in this question, we are using compounded monthly. So remember this thing, we actually will have to convert our interest rate. What is the approximate monthly payment? So we are actually calculating EMIs here. And this is what this question is about, annuity. So what is an annuity? So now let's talk about what is an annuities. I need some space. So basically, the definition of annuity is annuity bond. An amortizing bond is one that pays a level amount each period, including its maturity period. The difference between an amortizing bond and a fixed coupon bond is that for an amortizing bond, each payment includes some portion of the principal. What does this means? This question we actually have to do. So before we start, so there are annuity investments, annuity instruments actually. So they make periodic level payments. This means is payments consist of both interest and the principal, and this is most common in mortgages. So understand this thing. Let's assume this is a timeline. Here, this is representing our present value. This is the present value. I'm saying that this is a negative value. So present value I'm considering. That's why I have making it below the line, and above the line I'm assuming these are positive values. So this is a cash out, different color. So this is representing cash outflow. Here the borrower is actually receiving the money. Borrower is receiving the money at time zero. So this is time zero. And now understand this thing. So now we have X amount of money. We have taken a loan of X amount of money. Now every month we are going to pay a specific amount. So equated in monthly installments. So we are going to pay equal monthly installments here. So the installments are going to be same throughout the tenure of the bond, throughout the tenure of the loan. Let's assume that this is a uh, 6 month bond, 6 months, 6, 7. Let's make it a little long. 7, 8, 9, and 10. So let's assume that this is a 10-month bond. The definition is includes some portion of the principal. When we talk about bond, there is going to be interest, there is going to be yield, there is going to be time, there is going to be principal. There is going to be future value, there is going to be present value. Now understand this. So we are paying, okay, there is going to be PMT also. All the five factors out of five, four are given. We need actually four to calculate the last one. So we need four factors. Then we only will be able to calculate one. So every now and then they are actually paying you us in principal. So initially what happens is principal component is low. This is representing principal. And gradually and slowly the principal component increases. This is what an amortizing bond looks like. This is the principal component below, and at the end, there is no interest component. The interest component is, I mean, the interest component it decreases till the end. Not, it's not that it's not there. It is there. The interest component. I am saying that this is the interest component here. This is representing interest, and below interest, there is a the another portion is actually principal. This is, I'm saying that this is the principal component. So when, because why interest component is more in the initial time. So this is interest and this is representing principal. Yellow is representing interest and blue turquoise is representing principal. Why? Because as we go down the line, to the end of tenure, this is what we are going to discuss in fixed income, but I'm going to give you an overview here. Tenure, TENURE. So the risk of the bond increases in the initial phases. The risk of the bond, prepayment to reduce prepayment risk. This is structured in such a way, even though let's assume that this is $1,000 and this is a hypothetical number, since this is 1 2 3 4 5 6 7 8 9 10 11, these are 11 installments, so I'm assuming 100 principal here for every installment, 100 EMI for $100 payment for every installment, and I'm assuming that at the end of the tenure we are actually paying a $100 extra for the interest component. But understand this thing. Uh, Yield is when the tenure is large, so yield is actually sensitive here. So yield is actually sensitive, and because market actually goes in phases, so there is a time when the yield is high and there is a time when the yield is low. There's a time when yield is high and there's a time when yield is low. So if there is any change in the market rate of interest, uh, so what the borrower will do is borrower will pay its loan here, and then what they will do is they will take the loan at a lower price. If there is a, I'm saying that the yield of the, okay, here at this point, at the when the interest rate falls, if there is a fall in the interest rate, so there is the risk of prepayment for the lender actually increases. So that's why in the initial time period, the interest rate is actually higher. The interest is actually higher, and the principal component is lower. And slowly and gradually, when once they have actually recovered their interest component, uh, so they actually start recovering their principal. So initially the interest is higher, the interest component is higher, and principal component is low. And in the till, I mean, when the bond is towards its closure, the principal is high and the interest and principal. So principal is high and the interest component gets low. Interest is low, principal is high. Here the interest is high and the principal is low. So you need to understand this thing. Uh, this is the, I mean, this is the best I could think of. And we have not taken any interest rate here. We are not talking about interest. We have not calculated anything using an interest rate. This is just an hypothetical example. So x, okay, let's let it be. So this is just an hypothetical example. Understand this? And this is actually this is representing annuity. In perpetuity, you will be receiving certain or specific amount of cash flows in perpetuity. When we talk about perpetuity, you will be receiving a certain specific amount of cash flows, and initially you have paid a large amount here. Example, $200, and you will be receiving $10 throughout your tenure. And opposite to perpetuity, you have paid, you paid this, and this is perpetuity. We are talking about perpetuity. Here, when we talk about annuity, you have actually borrowed this money now. Now, let's assume you have, what should I use screen? So you have actually borrowed, let's assume $1,000. This is actually a cash outflow. This is a negative number, and these are all positive numbers. And opposite to perpetuity, there is annuity where this is a positive number. You have received this amount, you have taken this amount, and now you are paying $100 uh, quarter, every month, sorry. So every month you are paying $100, and this is actually an outflow. Now you are paying this $1,000 plus interest. Here you are getting, your interest is getting compounded at what rate? So the logic of perpetuity, it's because there is the time is infinite. That's why the perpetuity calculation is amount divided by R. Now understand this thing. This is actually simple formula. The formula is the present value is future value divided by 1 plus R to the power T. Now what I am saying is the time, we are not worried about the time. So future value is simply, this future value is impacted by uh, payment. So this actually changes to payment, and this 1 plus R actually changes to rate. So this becomes payment divided by rate. So this is the payment, the $10 we are receiving every now and then. This is what we discussed in the question. And when we talk about the rate was 0 point what? Let me just check. The rate was here in this question 0.005. And this rate was 0.005. And this gave us a value of $200. This is what perpetuity means. And perpetuity means, and annuity means you have borrowed the money and now you are paying back the money. And here you are the borrower and here you are the receiver. Okay, so let's do our question. Freddy bought a car for $42,000, and now he wants the required. What is the EMI? We actually have to calculate the EMI. 42,000 is the worth of the car. He has made a down payment of 15% now. So he has actually made a down payment of 15%. Now understand this thing. At time zero, time one, two, three, four. Here he has actually made a 15% down payment, and we actually want loan of, so the loan amount is 15% we have given, we have already made a down payment. So 85%, 85% of 42,000. This is the loan amount here. Now understand this thing. This is the loan amount here. And if we calculate this thing, this is going to be 35,700. This is the loan amount here. Now the remainder is to be paid as a monthly payment over the next 12 months. So N is going to be 12 here. It's 12 months. First payment is due at time one here. Given the interest rate of 8%, the compounded monthly. So this actually per annum, this interest rate is saying per annum. Now we need to calculate interest. Our interest is going to be 8 divided by 12. This is the loan. So this is the present value of the loan. We need to calculate what is the approximate monthly payment. And by the end of the tenure, at the end of 12 months, the loan's future value is going to be zero. Understand this thing because we are paying off the loan now. When we talk about annuity, we have taken this loan, and at the end of the period, we have actually paid this loan. Now we actually are paying off this loan plus interest component. So at the end of time 12, at the end of the 12th month, we have actually paid out our loan. So the loan's future value is zero. Here in this question, we are actually going to calculate the payment amount, PMT function. So now let's understand this thing. Let me just show you my calculator. So understand the future value is zero. Okay. Payment, this is in cash inflow. If this is an inflow, we are considering this as an inflow and the present value is an inflow. So, so this the payment is going to be a negative number because this would be an outflow. The calculator is assuming that this as an outflow. So you will be paying either you are saying that you receive this money and the present value, either you can say that the present value is positive number and future value is negative number because you are gradually paying off the loan. So here you are actually paying off the money. So EMI, just don't be alarmed when the PMT number comes negative. And you will understand this logic once you will start doing questions on your own. So I'm sharing my screen now. So clear work, second, clear work. Here, the future value is going to be zero because we are going to pay off the loan. Then N is going to be 12 because this is the number for period. The interest rate is going to be 8 divided by 12, and this is going to be our interest I slash Y. Present value is 35,500. 35,700. 35,700 is going to be our present value. Now we need to compute the payment. So every month, Friday actually need to pay 3,105.49 negative. So every month, Friday actually need to pay three 3,105.48 as an EMI. It's all gotten messy little here, so I hope, but still you understood what I'm trying to convey here. And we are only talking about the bond components as of now. We have not uh, started with our equity instruments. There is a when we started about this LOS actually is about fixed income as well as equity instruments. So okay, so there are few more examples here. Then we will start with our equity instruments. Zero coupon bond with a negative yield, zero coupon bond with a negative yield. And yes, there could be a reason zero coupon bonds could be with a negative yield. This means, uh, see, the rate is 0.05. So if I were to plug in this thing into in manually in the formula, so present value would be future value 1, now it's minus 1 minus 0.05. This is 0.05 raised to the power t. So this is what it would have looked like. 1000 divided by 1 minus 0.005 raised to the power 15. And we would have calculated the annual compound and what yield to mature. Okay, this is a bonus previous. What is the price? Price is the present value. So they are asking what is the price assuming annual compounding. And PMT is here. PMT is zero because this is a zero coupon bond. Yield is I slash Y. We have minus 0.0, minus 0.5. Uh, okay, in the previous example, in this zero coupon bond here, they are talking about. So future value is 1000. This is the future value. Time is 15, N is 15. Now, if we plug these numbers into a calculator, now again sharing my calculator screen with you. Second clear work. Now, N is going to be 15. So this is a 15 years zero coupon bond. The interest rate is 0.5 negative. This is how you actually put negative interest rate. Present value we actually have to calculate because this is a zero coupon bond, payment is going to be zero, and at the end of the tenure the investor is going to get a face value of future value of $1000. So now I need to compute the present value, and the present value is 1078.89. 1078.79. So for this bond the investor actually need to pay 1079. Let me just see what was it. One, the investor need to pay $1078.09. This means this actually is a premium bond. Okay, so now uh, let's do our two more examples. We are left with two more examples. Price of an annual coupon bond. So here, this bond is paying a coupon annually. Consider a 10-year $1000 par value. Par value, when they are saying par value, this is the future value, face value. 10% coupon bond. The tenure N is 10. This is N. This is FE. This is I slash Y. Annual pay bond. What is the value of the bond if the yield to maturity is 8%? This is, okay, sorry, this is not IY. This is PMT. And this is I slash Y. Now, before we start, the coupon payment is greater than maturity. The coupon payment, the coupon payment is greater than yield. My bad. The coupon payment is greater than yield. The coupon payment is 10%, and the yield to maturity is 5%. So I am saying that whatsoever we calculate, the bond is going to give us a premium value. Let's plug in these numbers into a calculator, and you will see why. Second clear work. So this is a 10-year bond, N is 10. $1000 par value means this is what we are going to get in the future. 10% discount means the, okay, 10% of 1000 is 100. So we are going to plug in 100. Yield to maturity I slash Y is 8%. Compute the present value. So this bond is going to give us a present value of 1134.20. So the present value of the bond is $1134.20. And this is actually a premium bond. If you actually, okay, so we do not have to calculate these, so we do not have to, this, the CF exam is actually MCQ, multiple choice question, multiple choices. So there will be multiple choices when we will be appearing for our CF exam. So understand this thing. We do not have to calculate all these things in the sheets, but what we actually have to do is uh, what we can do based on this information as of now. So if we have options, so let's say the option is $1,000, the another option is $1,200, and the third option is $900. So we can choose on the basis of information that the option is going to be a premium. So this will actually save our time. Okay. So last question here. So last question is computing a loan payment. So suppose you are considering applying for a $2,000 loan that will be repaid with equal end of year payment over the next 13 years. If the annual interest rate for the loan is 6%, how much will you pay? And this is again an annuity question. So here this is actually a question where we are actually where they're actually talking about annuity. Now, if you understand the context of the question, suppose you are considering to apply for a $3,000 loan that will be repaid with equal end of the payment, equal and year end payments over the next 13 years. Here, this is actually representing a PMT, but this here we are actually paying, we are not receiving. So annuity is opposite of perpetuity. If the annual interest rate for the loan is 6%, how much would you pay? So simply we actually have suppose you're considering applying for this. This is actually loan amount. So this is our present value. We are having this much value, 2,000 dollars over the next year. So N is equals to 13 years. If the annual interest rate I slash Y is 6%, we actually need to calculate the PMT. What would be the PMT? And remember this thing. The future value, since we are paying off the future value is going to be zero. So let me just share my calculator with you now. So we will plug in these numbers into a calculator. Okay, so N is equals to 13 years. So this is a 13-year investment. IY is going to be 6. This is $200. So this is the present value. We actually have to calculate the PMT. So future value is 0. Now we need to compute the PMT. So PMT is going to be 225.92. And PMT is going to be a negative number because we considered that the present value is going to be a positive number. So that we have considered that present value is an inflow. So the loan amount, we said this was an inflow to us. So this is going to be a negative number because this is going to represent a negative outflow. This is actually going to be an outflow for the investor. So whosoever is the loan bearer, they actually have to pay this payment. And this payment actually includes a certain portion of interest as well as a certain portion of principal. So if I actually multiply this with 13 years, 13, this is a 13-year loan, we are going to receive we, so this is actually a 13-year loan, yes, 2936.96. So this much an investor would have paid uh, PM payments. Let me just do it one more time. Compute PMT 225.92. This is actually how much an investor would have uh, paid 2936. So they actually borrowed 2000 rupee, $2,000, and they paid back 2936 along with interest. So 936 is going to be your interest component. So throughout the tenure, if you calculate how much you have paid along with the principal, so principal was 2000. So if I subtract now, actually, uh, if I subtract $2,000 out of it, so 936 is the interest component which we paid apart from our principal component. So, okay, so I hope you understood what does this means now. So the PMT is going to be 225.92 dollars. So that's it for today. So in the next session, we are going to start with our equity securities. The LOS, I'm again coming back to the LOS, calculate and interpret the present value of fixed income based on expected future cash flows, present value of equity instruments based on expected future cash flow. So based on expected future cash flow, the fixed income securities are divided into discount, zero coupon, perpetual, or annuity. So this could be a pure discount bond. This could be a zero coupon bond. This could be a fixed income bond, fixed coupon bond. So the coupon rate is fixed. There could be no bond, no coupons. Zero coupon means no coupon. Fixed coupon means it's in itself evident that what the it I mean, if you understand the name, so it's saying what it's saying. Perpetuity and annuity. Perpetuity, just remember this example. So this perpetuity bond do not have a maturity date, and an amortizing bond, here we are actually calculating EMIs. So just remember the usage of amortizing bonds and the usage of perpetuity bonds. So no maturity date. So this bond is going to be paying you coupons till infinite. Thank you for attending this session today. I'll see you in next session.